Students, let us continue our discussion on complex numbers. In the last class, we have seen that if z is equal to x plus y, then the polar form of this complex number is z is equal to r into cos theta plus I sin, where r is the modulus which is obtained as root of x square plus y square, and theta is the amplitude which is obtained as, again, there is no direct formula, it depends on where that point is situated, where is that point x comma y. First we find out alpha. Alpha is equal to tan inverse of modulus of y by x. Then if the complex number lies in the first quadrant, then theta is equal to alpha. If it's in the second quadrant, theta is equal to pi minus alpha. If it's in the third quadrant, theta is equal to alpha minus pi. And if it is in the fourth quadrant, then theta is equal to minus alpha. That much we know. Okay. So now z is equal to r cos theta plus I sin, r into cos theta plus I sin theta, where r is the modulus and theta is the amplitude. This is called the polar form of this complex number. Okay. So from this, there is a theorem called De Moivre's theorem. What is that De Moivre's theorem? Let us discuss. De Moivre's theorem. What does this say? Cos theta plus I sin theta whole power n is equal to cos n theta plus I sin n. Cos theta plus I sin theta whole power n is equal to cos n theta plus I sin n. And suppose if you have cos theta minus I sin theta whole power n, then what happens? Then I can write like this: cos of minus theta. I am writing cos theta as cos of minus theta, okay? Because we know cos of minus theta is cos theta itself. And here you have minus I sin theta. No, I am writing that as I sin of minus theta whole power. Okay. Now it is of the same formula. Instead of theta, we have minus theta. That's all. Use the same formula here also. We get cos of minus n theta plus I sin of minus n. Cos of minus n theta is same as cos n theta, and sin of minus n theta can be written as minus I sin n. Right. So from this we can directly write that cos theta minus I sin theta whole power n as cos n theta minus I sin n. Then we have another formula, that is cis alpha into cis beta is equal to cis of alpha plus beta. How it is? Let me explain. Cis alpha into cis beta. I have already told you cis theta is equal to cos theta plus I sin theta. So cis alpha is cos alpha plus I sin alpha into cis beta, which is cos beta plus I sin beta. Okay, that's equal to, now you multiply cos alpha cos beta plus I into cos alpha sin beta plus I into sin alpha cos beta plus I square sin alpha sin beta. I square is minus 1, so this will become minus sin alpha sin beta. That's equal. Now look at this. Cos alpha cos beta minus sin alpha sin beta can be written as cos of alpha plus beta. Cos a plus b is equal to cos a cos b minus I cos a. And between these two, I will take I as a common factor. So if I take I as a common factor, then we are left with cos alpha sin beta plus sin alpha cos beta. Okay. So that's equal to cos of alpha plus beta plus I into cos alpha sin beta plus sin alpha cos beta. It looks like sin a cos b plus cos a sin b, which is equal to sin a plus b. So I into sin of alpha plus beta. Cos theta plus I sin theta is called as cis theta. So cos of alpha plus beta plus I sin of alpha plus beta is equal to cis of alpha plus beta. So we can say cis alpha into cis beta is equal to cis alpha plus beta. Okay. Actually we can extend this result also. That is, instead of alpha and beta, if we have some more, cis alpha into cis beta, cis alpha into cis beta into cis gamma into cis delta, and so on. Then we can write this product as cis of alpha plus beta plus gamma plus delta plus theta, eta, etc. So in this way, then further we can write cis alpha divided by cis beta as cis of alpha minus beta. Cis alpha by cis beta is equal to cis of alpha minus beta. Then argument of z1 into z2 is equal to argument of z1 plus argument of z2. Then argument of z1 by z2 is equal to argument of z1 minus argument of z2. Argument of z1 by z2 is equal to argument of z1 minus argument of z2. Okay. So another thing which I forgot to mention in the last class is the inverse, additive inverse and multiplicative inverse. See, 0 is also a complex number because you can write 0 as 0 plus I into 0. So 0 is the additive identity for the complex number, which means z plus 0 is equal to 0 plus z is equal to z. If z is any complex number and you add 0 to that complex number, you will still get that complex number only. Then multiplicative inverse. So if 0 is the additive identity, then additive inverse for z minus z is the additive inverse, because if I add z with minus z or you add minus z with z, you will see that sum is same. Then multiplicative identity. 1 is called the multiplicative identity. 1 can be written as 1 plus I into z. Let z be any complex number, then z into 1 is equal to 1 into z is equal to z. Okay. So 1 is the multiplicative identity. Then what is multiplicative inverse? So for z, the multiplicative inverse is 1 by z, because the product will be equal to 1. Okay. So you will get a question like this: find the multiplicative inverse of 3 plus 2y. Then if you simply write 1 by 3 plus 2y, that may not be enough, may not be there in the options. Okay. Of course, it is true that the multiplicative inverse of 3 plus 2y is 1 by 3 plus 2y. But this may not be there in the options, because usually in the options they will give you in the standard form. Standard form means a plus ib or x plus iy. So then what you should do, you simplify this, bring it to the standard form. 3 minus 2y, that's equal to 3 minus 2y divided by a plus b into a minus b, that will give you a square plus minus b square. So here you will get 9 plus 4. 9 minus of minus I square into 4 you get. I square is minus 1, so it will become 9 plus 4. So this will be equal to 3 minus 2y divided by 30. So from this we can say that multiplicative inverse of a plus ib is equal to a minus ib divided by a square plus b square. Multiplicative inverse of a plus ib is a minus ib divided by a square plus b square. How it is so? How it is true? Because the product of these two, if I multiply these two, a plus ib into a minus ib will give you a square minus I square b square. A square is minus 1, so it will become a square plus b square. Denominator also a square plus b square. That gets cancelled, so you get 1. So remember that the multiplicative inverse of a plus ib is a minus ib divided by a square plus b square. Very easy to remember. In the numerator, we just take the conjugate of this, and in the denominator, it is the square of its modulus. Modulus of a plus ib is root of a square plus b square. Its square is a square plus b square. So remember this formula so that you can directly get the answer. Even if you cannot remember also, no problem. You write a plus ib as 1 by a plus ib, then you simplify it and bring it to the standard form, you will get the answer. Okay. This is about the multiplicative inverse. Now I will discuss the nth roots of unity. Nth roots of unity. Unity is nothing but 1. Let us see what are the nth roots of unity. See, this is an equation x power n is equal to 1. It is a polynomial equation of degree n. So it has n roots. The roots of this equation are called the nth roots of unity. Okay. So now, if I put different values for n, suppose if I take n is equal to 2, x square equal to 1, the roots of this equation are called the square roots of unity. So this is a polynomial of degree n, therefore it will have n number of roots. This is a polynomial of degree 2, so it will have 2 roots. Those 2 roots are plus 1 and minus 1. So that implies x is equal to plus or minus 1. Then I will put n is equal to 4. For n equal to 3 I will come back afterwards. X power 4 is equal to 1. Now, so the roots of this equation are called the fourth roots of unity. What are the fourth roots of unity? So 1 is a root, obviously it is true. Minus 1 is also a root, minus 1 whole power 4 is 1. What about the other 2 roots? That I shall find out. X power 4 is equal to 1 we have, I write x power 4 minus 1 is equal to 0. I am writing this as x square whole square minus 1 square equal to 0. This is of the form a square minus b square. A square minus b square can be written as a minus b into a plus b. That's equal to 0. This will imply that either x square is equal to 1 or x square is equal to minus 1. X square is equal to minus 1 means x square equal 1 means x is equal to plus or minus 1. X square equal minus 1 means x is equal to plus or minus root of minus 1. Root of minus 1 is nothing but I. So the roots of this equation are 1, minus 1, I and minus I. These 4 are called the fourth roots of unity. You can observe that all of this will satisfy. 1 power 4 is 1, of course it is true. Minus 1 power 4 is also equal to 1. I power 4 is 1, we already know. Minus I whole power 4 can be written as minus 1 power 4 into I power 4. That is also equal to 1. So these 4 will satisfy this equation. These 4, 1, minus 1, I and minus I, they are called the fourth roots of unity. Now let us look at the cube roots of unity, the all important one. The cube roots of unity. The roots of this equation, x cube is equal to 1. See, in this equation, x power n equal to 1, the roots of this equation are called the nth roots of unity. So I am putting n is equal to 3 now. The roots of this equation are called the cube roots of unity. X cube equal to 1. I am bringing 1 to LHS, so x cube minus 1 is equal to 0. I will write 1 as 1 cube now. Now this looks like a cube minus b cube. Already we know that a cube minus b cube is equal to a minus b into a square plus ab plus a square. That will give you a minus b into a square plus ab, x into 1 that is plus b square, 1 square which is 1 is equal to 0. So now this product is 0 means either this is 0 or this is 0. By equating this to 0, we get x equal to 1. By equating this to 0, we get this is a quadratic equation, so 2 more roots we will get it from here. So x minus 1 equal to 0 will imply x equal to 1. This is one of the roots. I want 2 more roots which must be obtained by solving this quadratic equation. Okay, let us solve this quadratic equation. This cannot be factorized easily. So I will go for the formula. Minus b plus or minus root of b square minus 4ac by 2a. A well-known formula that I am using now. Minus 1 plus or minus root of b square which is 1 minus 4ac divided by 2a. That's equal to minus 1 plus or minus root of minus 3 divided by 2. So root of minus 3 is there, I will write that as root of minus 1 into root 3. Root of minus 1 is nothing but I. So the roots of this quadratic equation are x is equal to minus 1 plus or minus I root 3 by 2. Okay. So the cube roots of 1 are 1 is one root. The other 2 roots are minus 1 plus I root 3 by 2 and minus 1 minus I root 3 by 2. Okay. So 1 is one root, minus 1 plus I root 3 by 2 is one more root and minus 1 minus I root 3 by 2 is the other root. These 3 roots are called the cube roots of unity and usually this is denoted by omega. Omega is equal to minus 1 plus I root 3 by 2. If this is denoted by omega, then this will be omega square. Omega square is equal to minus 1 minus I root 3 by 2. Now you might be wondering, sir, if I call this as omega, then how can this will be equal to omega square? Let me show you how. Omega square equal to squaring this minus 1 plus I root 3 by 2 whole square. That's equal to. So here I am using a minus b whole square formula. A square is 1 plus b square I square into 3 minus 2ab, that will give you minus 2I root 3. In order to be 4 whole square which is 4. How? This I square is equal to minus 1. So this you will get 1 minus 3, that's equal to minus 2 minus 2I root 3 by 4. I will take 2 as a common factor. So So if I take 2 as a common factor, in the numerator we are left with minus 1 minus I root 3. 2 gets cancelled. So this will give you minus 1 minus I root 3 by 2. That's what we have here. Minus 1 minus I root 3 by 2. So this is omega and this is omega square. Hence, we can say that 1 omega and omega square, 1 omega and omega square are the cube roots of unity. In that, 1 is called the real root of unity, real cube root of unity, and omega square, because they are the complex numbers, those two are called the complex cube roots of unity. Okay. Now let us discuss one or two properties of that. And then we will go to problems. Sum of these cube roots of unity. What is 1 plus omega square? Let us see. 1 plus omega. Omega is substitute minus 1 plus I root 3 by 2 plus omega square, which is minus 1 minus I root 3 by 2. Okay. Let us simplify this. 1. I'll write this as minus 1 by 2 plus I root 3 by 2. This is minus 1 by 2 minus I root 3 by 2. So this I root 3 by 2 gets cancelled. Minus 1 by 2 minus 1 by 2 will give you minus 1. 1 minus 1, that's equal to 0. So remember this, 1 plus omega square equal to 0. This need not remember all this proof. Nobody will ask you the proof. But you need to remember this formula. 1 plus omega square is equal to 0. A very useful result. Okay, we may not be using the same formula, same version of the formula. We will be using different version. Say in some cases you may be able to write, you need to write omega plus omega square as minus 1, or 1 plus omega as minus omega square, or 1 plus omega square as minus omega. But for all these are derived from this formula. Remember this, a very important one. 1 plus omega square is equal to 0. Let us look at one more property of that. Omega cube is equal to 1. So this also you should remember. How it is true, let me explain. As you know, omega is equal to minus 1 plus I root 3 by 2. Now I want omega cube. That is, I can write this as I root 3 minus 1 by minus 1 plus I root 3 by 2 whole cube. That's equal. In the denominator, 2 cube is 8. In the numerator, I am using a minus b whole cube formula. A minus b whole cube. You know the formula, a cube, that is I root 3 whole cube. Minus b cube, 1 cube, that is 1 x. Minus 3ab, that is 3I root 3. Into a minus b, I root 3 minus 1. Okay. Let us simplify this. Here, I cube into root 3 whole cube. Root 3 whole cube can be written as 3u. I cube is minus I. So this will become minus 3 root 3I minus 1. This product, root 3 into root 3 will become 3. 3 into 3, 9. I into I is I square. Minus 1 into minus. So this will become plus 9. And here minus 3I root 3 into minus 1. So that will give you plus 3 root 3 into 5. Divide by 8. Observe. 3 root 3I minus 3 root 3I gets cancelled. 9 minus 1 is 8, and 8 by 8 is equal to 1. So we observe that omega cube is equal to 1. Now not only omega cube, from this we can say what is omega power 4. Omega power 4 is equal to omega cube into omega. Omega cube is 1 into omega, that is omega. Omega power 5 is omega cube into omega square, that's equal to omega cube is 1 into omega square is omega square. Then omega power 6 is nothing but omega cube into omega cube, that's equal to 1 into 1, which is 1. So in general, we can write omega power 3n is equal to 1, where n is any positive integer. Then what about omega power 3n plus 1? That's equal to omega power 3n into omega. Omega power 3n is 1 into omega. 1 into omega, that's equal to omega. Then omega power 3n plus 2, that's equal to omega power 3n into omega square. Omega power 3n is 1, so 1 into omega square is equal to omega square. So these things you must remember. Okay, students, actually still some more synopsis I have to discuss, which I will discuss in the due course of time whenever we come across problems of that kind I will discuss. So now let us discuss problems. Okay, open your book, look at question number 1. That question number 1 will appear here also on the board. Okay, question number 1. Root of minus 5 into root of minus 125. This is what we want to find. Okay, say here root of minus 5 into root of minus 125 they have asked. Root of minus 5 into root of minus 125. I'll write root of minus 5 as root 5 into root of minus 1. Similarly, root of minus 125 can be written as root of 125 into root of minus 1. Okay? Now, root 5 I will write as root 5 only. Root of minus 1, we know that is I. Root of 125 I am writing it as 25 into 5. 25 into 5, in that I will take out the 25 out of this root, that will be 5. So 5 will be 5 into root of minus 1 is I. Now root 5 into this root 5 is 5, 5 into 5 is 25, so this is equal to 25 into I square. I square value we already know, which is minus 1. 25 into minus 1 is equal to minus 25. That's the answer. Second option, minus 25. Okay. Let's go to the next question. Question number 2. If I is equal to root of minus 1, which we know, and n is a positive integer, then I power n plus I power n plus 1 plus I power n plus 2 plus I power n plus 3 is equal to, what is its value? That we have to find out. See, we have to find out I power n plus I power n plus 1 plus I power n plus 2 plus I power n plus 3. Okay. So from these 4 terms, I will take I power n as a common factor. If I take I power n as a common factor, then what will remain here? 1 will remain. What will remain here? See, I power n plus 1 can be written as I power n into I. I power n into I. With that I have taken I power n now. So I will remain. Then I power n plus 2 can be written as I power n into I square. I power n I have taken out. So I square. Then I power n plus 3 is I power n into I cube. I power n I have taken out. So I cube. Okay? That's it. I power n into 1 plus I. I square value we already know. What is the value of I square? Minus 2. What about I cube? I cube is nothing but minus I, because I cube is equal to I square into I. I square is minus 1 into I will give you minus I. See what happens here? 1 gets cancelled, I gets cancelled. What will remain? I power n into 0 is equal to 0. That's the answer. Second option. Okay. Let's go to the next question. The least positive integer n for which 1 plus I whole power n divided by 1 minus I whole power n minus 2 is a real number. The least positive integer n for which this expression is a real number. That is what we want to find out. Now, so look at that expression. That expression is 1 plus I whole power n divided by 1 minus I whole power n minus 2. Okay? We want to find out what is the least positive integer n for which this expression must be a real number. Okay. So 1 minus I whole power n minus 2 is there. I can write this as 1 minus I whole power n into 1 minus I whole power minus 2. And after that I am taking this 1 minus I whole power minus 2 to the numerator. So that power will become plus 2. So 1 plus I whole power n into 1 minus I whole square divided by 1 minus I whole power n. Okay? This is what we have. Now this is equal to 1 plus I divided by 1 minus I whole power n into 1 minus I whole square. Expand that using a minus b whole square formula. With a square plus b square minus 2ab minus 4. That's it. We shall simplify this. 1 plus I by 1 minus I. Let us multiply and divide by 1 plus I. So 1 plus I by 1 minus I into 1 plus I by 1 plus I. I am multiplying and dividing by 1 plus I. Here what happens? What is the value of I square? I square is minus 1. So 1 minus 1 gets cancelled. We will have minus 2. Okay. And here what happens? Just observe. 1 plus I into 1 plus I, that is 1 plus I whole square, that will give you 1 plus I square plus 2. Denominator is 1 minus I into 1 plus I, that will give you 1 minus I square, so 1 plus 1, 2. Whole power n into minus 2i. Okay. I square is minus 1, that 1 minus 1 gets cancelled. 2i by 2 is equal to I. So you have I power n into minus 2i. That's equal to, I can write that minus 2 into I to the power n plus 1. I to the power n, I power n plus 1. Okay. So this expression, after all the simplification, we get minus 2 into I to the power n plus 1. Now, the least positive integer value for n, so that this becomes a real number. This is a real number. This is a real number means this factor should not be there. This should not be there means if the power is 0, then also it will not be there. But power is 0 means n plus 1 must be equal to 0, so n must be equal to minus 1. That cannot be the answer because they have given positive integer. Okay, I cannot take n equal to minus 1. So then looking at the options, what I can think of? I can think of 1 first because among them that is the least. Okay, but directly I cannot say that is the answer. N is equal to 1 answer. 1 if I substitute 1 plus 1 is 2. What is I square? I square is minus 1. Minus 2 into minus 1 you get 2. Is it a real number? Yes. So the least value of n is equal to 1. Okay. Then let's go to the next question. Okay. Now you might be thinking, sir, after third question, why you have gone to fifth question? Okay. It's because don't expect me to solve each and every question what is available in the material. Okay. We don't have that much time. So in every class what I am going to do is I will solve the selected problems only. Whatever the problems that I have left in between, that is homework for you. And with that, any doubts if you have, you can ask through WhatsApp groups. Okay. So looking at this question, 1 plus I whole power 6 plus 1 minus I whole cube. Okay. So I will solve this by two methods. Okay, I'll solve this by two methods. See whichever is easy you get one. 1 plus I whole power 6. I'll write this as 1 plus I whole square plus 1 minus I whole cube. Use a minus b whole cube formula. I'll do it in next. That's it. 1 plus I whole square, if I expand it, a square plus b square plus 2a whole plus a minus b whole cube. A cube, that is 1 minus b cube I cube minus 3ab is 3i into a minus 1 minus 1. Here I square is minus 1. 1 minus 1 gets cancelled. So you have 2i plus 1. I cube is nothing but minus I. So you know plus minus of minus I plus minus 3i plus 3i square, that will be minus 1. Minus 3i into minus I means plus 3i square. I square is minus 1. So minus 1 into plus 3, that will be minus 3. So I cube, 2i whole cube means 2 cube which is 8 into I cube is minus 1. This will be minus 3i plus 1 minus 3, that is minus 2. I minus 2, 3i is minus 2. So this will be minus 2 minus 10i. Minus 2 minus 10i. Do we have this option? Yes, we have option C. Okay. So I told you, I'll give you one more method also. You write 1 plus I. You want 1 plus I whole power 6 plus 1 minus I whole cube. I'll write 1 plus I in polar form. Okay? 1 plus I in polar form. What is the modulus of this? X is equal to 1 here, y is also 1. So modulus is equal to root of x square plus y square. Here we will get 1 square, root of 1 square plus 1 square, which is root 2. Okay. Modulus is root 2. Then what about theta? 1 plus I, which is represented by the complex number 1 comma 1, represented by the point 1 comma 1, which lies in the first quadrant. So when that complex number lies in the first quadrant, theta is equal to alpha. Alpha is tan inverse of mod y by x. So tan inverse of modulus of 1 by 1, that is 1. Alpha is equal to tan inverse of modulus of 1 by 1, that's equal to tan inverse 1, which is pi by 4. So first quadrant theta is equal to alpha. So we got theta is equal to pi by 4. R is equal to root of x square plus y square. So this will be equal to root 2 into 6 pi by 4 whole power 6 plus 1 minus I, which is the conjugate of 1 plus I. 1 minus I is the conjugate of 1 plus I. So modulus will remain the same. And what happens to the amplitude? Okay. See, which I forgot to mention in the last class. If theta is the amplitude of z, then minus theta will be the amplitude of z bar. Okay. For z and z bar, modulus will remain the same and amplitude will be negative of the other. Okay. If theta is the amplitude of z, then minus theta is the amplitude of z bar. So in this case, 1 minus I is the conjugate of 1 plus I. For 1 plus I, modulus is root 2. Therefore, for 1 minus I also, modulus must be equal to root 2. Then amplitude, for 1 plus I, the amplitude is pi by 4. Therefore, for 1 minus I, the amplitude must be minus pi by 4. So, root 2 into cis of minus pi by 4 whole cube. Okay? If you want, you can cross check that. Here alpha is tan inverse of modulus of y by x is minus 1 by 1. Minus 1 by 1. That is 1 only. Modulus of minus 1 is 1. Tan inverse 1 is pi by 4. But theta will be equal to, now 1 minus I, where does it lie? 1 minus I, that complex number is represented by the point 1 comma minus 1. 1 comma minus 1 lies in the fourth quadrant. So in the fourth quadrant, theta is equal to minus I. So we get minus pi by 4. Right? Then root 2 whole power 6, that will be 2 cube into 6 pi by 4. How? I am using De Moivre's theorem. What does De Moivre's theorem say? Cos theta plus I sin theta whole power n is equal to cos n theta plus I sin n theta. This is what De Moivre's theorem says. Cos theta plus I sin theta whole power n is equal to cos n theta plus I sin n theta. Now, this in short form we write this as cis theta whole power n. In short form we write this as cis n theta. Okay? Cos n theta plus I sin n theta is nothing but cis n theta. So cis n theta, it is by what n theta plus root 2 whole cube, that will be 2 into cis of minus 3 pi by 4. That's equal to 2 cube is 8. 6 pi by 4 is nothing but 3 pi by 4. So cis 3 pi by 2 means cos 3 pi by 2 plus I sin 3 by 2 plus 2 root 2 into cos of minus 3 pi by 4. Minus 3 pi by 4 can be written as plus 3 pi by 4. Plus I sin of minus 3 pi by 4. That will become minus I sin 3 pi by 4. Sin of minus theta is equal to minus I sin. Cos 3 pi by 2, cos of mod multiple of pi by 2 is 0. Sin 3 pi by 2 is minus 1. So 8 into minus I will get, which is minus 2 plus 2 root 2 into cos 3 pi by 4, which is minus 1 by root 2 minus 3 pi by 4, 135 degree, cos 135, 180 minus 45, second quadrant negative minus 1 by root 2. Don't expect me to explain all those things. Sin 3 pi by 4, that is 1 by root 2 minus z, so minus I into 1 by root 2. Okay, so minus 8i here root 2 gets cancelled. If I take inside, it will become minus 2, and here also root 2 gets cancelled, you will get minus 2. So that will give you minus 2 minus 10 9. Minus 2 minus 10 9. See, in the earlier method also, we had got the same answer. So you can choose which one is easy. Now let us discuss the next question. Question 6. The value of sigma n from 1 to 13 I power n plus I power n plus 1, where I is your root of minus 1, is summation n from 1 to 13 I power n plus I power n plus 1. This is what we have to find out. Okay. So now, before I put values for n, I will take I power n as a common factor. Okay. Then what will remain? 1 plus I power n I have taken common factor. Here I power n plus 1. So I power n into I. In that I have taken I power n out. So what will remain? I mean I power 1 will remain. This is I. This 1 plus I is independent of n, which can be taken out of this numbers. So 1 plus I into summation n from 1 to 13 I power n. Now go on substituting value for n starting from 1 till 13. So I power 1 plus I square I cube plus I power 4 I power 5 and so on until I power 12 plus I power 10. What is I square? Minus 1. What is I cube? Minus 8. What about I power 4? 1. I power 4 is 1. So 1 minus 1 gets cancelled. I minus I gets cancelled. So among these 4 terms, everything gets cancelled. I minus I square is minus 1. I power 4 is plus 1. Those 2 gets cancelled. Right? In this way, this gets cancelled. Similarly, I power 5 plus I power 6 plus I power 7 plus I power 8, that also becomes 0. And I power 9 plus I power 10 plus I power 11 plus I power 12 will also become 0. Then what is left? I power 13 will be left. So till here everything will be 0. I mean sum of all those will be 0. So you have 1 plus I into I power 13. I power 13 can be written as I power 12 into I. I power 12 is 1 because you know I power 4n is equal to 1. I power 4 is 1. I power 4 whole cube, that's equal to 1. So I power 12 into I power 12 is 1, I will divide. Now multiply this I into 1 is I times I square, I square is nothing but minus 1. So you get minus 1 plus I. In other words, I minus 1. That itself we have I minus 1 is the answer. Second option, I minus 1. Okay, let us go to the next question. Tenth question. The value of 1 plus I whole power 2n plus 1 divided by 1 plus I whole power 2n plus 1 divided by 1 minus I whole power 2n minus 1. Okay? This is equal to, I am writing this as 1 plus I whole power 2n into 1 plus I. Denominator is 1 minus I whole power 2n into 1 minus I to the power minus 1. So it will go to the numerator. Here together I can write it as 1 plus I divided by 1 minus I whole power 2n into, this will go up, so you will have 1 plus I into 1 minus I. Now I will multiply and divide by the conjugate of the denominator. Denominator is 1 minus I, its conjugate is 1 plus I. I am multiplying and dividing by 1 plus I. So this will give you 1 plus I by 1 minus I into 1 plus I by 1 plus I whole power 2n into a plus b minus b is a square minus b square. So 1 plus 1 square minus I square will become 1 plus 1 I square. This is equal to, here 1 plus I whole square is the numerator, that will give you 1 plus I square plus 4. I am using a square a plus b whole square formula. A square plus b square plus 2a divided by 1 minus I and 1 plus I, that will give you 2. 1 square minus I square. I square is minus 1, so 1 plus 1 whole power 2n into, what is I square? Minus 1. 1 minus 1 gets cancelled. y by 2 is I. Okay? Y by 2 is I. I to the power 2n into 2. I power 2n is nothing but I square whole power n into 2. What is that I square? Minus 1. Minus 1 whole power n is into 2. Okay. If n is odd, this will be minus 1. If n is even, it will be plus 1. So when n is odd, it will be minus 1. Minus 1 into 2 will give you minus 2. When n is even, power will be minus 1 power even number, it will be plus 1 into 2 will give you 2. So in either the case, whether n is positive or negative, this, whether n is odd or even, when n is odd it will be minus 2, when n is even it will be plus 2. So the answer is plus or minus 2. Okay, students, with this I will stop today's class. You try as many problems as you can in between all the problems whatever that I have left. If you have any doubts, you can ask me. Thank you.